juice like a snow cone. Ice in my veins and a cold flow. I'm getting cash overseas by the boatload. You wanna ride my wave? That's a no-go. Senoritas going loco. Make it bounce like a pogo. All my haters see rojo. They big mad cause they coming up short like Frodo. Activate.
In this tutorial, I want to talk to you guys about using modules in Python. Now, a module is essentially just a Python file that we can import into our current Python file. So, for example, if I wrote a Python file that had a bunch of like useful functions or useful variables or other things like that, I could take that file, I could import it into the file I'm currently working on, and I could actually access all of those functions, all of those variables, all the stuff from that external file inside the file that I'm currently working on. So I'm going to show you guys how we can use modules, and then we'll talk about where you can find awesome modules and really why modules make Python an awesome language. So over here in my text editor, I actually created this file, and it's called usefultools.python. And basically this file just has a bunch of sort of like useful tools that I might want to use in one of my programs. So you'll see over here I have some variables. This one is telling me how many feet are in a mile. This one's telling me how many meters are in a kilometer. And then we have this list here which lists out all of the members of the Beatles. I also have a couple different functions down here. So I have this get file extension function, and this basically just will, you give it a file name, it'll tell you what the extension is. And then we have this other function down here which simulates rolling a dice. So you pass it a number. If I pass it like a 6, it would roll a 6-sided dice. If I pass it a 9, it roll a 9-sided dice, etc. So this is like a Python file that I wrote, and it has some useful stuff in it. And honestly, there's a lot of stuff in here that I might want to use in the other Python files that I work with. So let's say I'm over here at this app.python file, and I'm thinking to myself, I think I could use one of those functions that was inside of that useful tools file. Actually, yeah, I need to simulate rolling a dice in my program. Well, instead of having to go over here, copy this function, and then paste it over here into my program, I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just going to go right at the top of my file, and I'm just going to say import, and then I want to type in the name of the file that I want to import. So I'm just going to say here, and I'm just going to go right at the top of my file, and I'm just going to say import, and then I want to type in and paste it over here into my program. I can actually just import this useful tools file, and I'll be able to import all of these functions and all of these variables and attributes. So the way I can do that is just by coming up here, and I'm just going to go right at the top of my file, and I'm just going to say import, and then I want to type in the name of the file that I want to import. So I'm just going to say useful_tools. And Python's going to be smart enough to know that it should go off and grab all the stuff from this usefultools.py file. So once I've used that import statement, I can actually use all of the functions inside of that useful tools file. So for example, I could simulate rolling a dice. I could say useful tools dot, and now I'm actually able to access all of the attributes from inside that file. So when I say useful tools dot, you'll see down here in my little suggestions menu, it's telling me like Beatles, feet and miles, get file extension, meters and kilometers, roll dice. So it's giving me access to all of the stuff that was in that file. So over here I could just say like roll dice, and we could pass this like a 10. We'll roll a 10-sided dice. And now this should actually be able to run that function. So we'll simulate rolling a 10-sided dice. So you can see we got 4. And this is a really core concept in Python, which is importing functionality from external Python files. And this is like huge in Python, and this is seriously going to change the way that you create your Python files. So you'll notice like I didn't have to copy any functions or any variables or anything over into this file, and yet I was able to use all the stuff that was inside this useful tools file. So that is huge, and honestly, it's going to save you a lot of time because you can write something once and then you can import it into your other files. And so that's really the basics of using modules. I mean, modules are very simple. A module is just any external Python file that you want to use some stuff inside of it. I want to show you guys a place where you can go to find a huge list of modules. So I'm going to go over here to my web browser, and I'm on this website. It's actually like the official Python docs. And basically all I did to get here was just type in list of Python modules in Google. And depending on the version of Python you're using, you're going to want to make sure that you click the right one. I clicked on the version 3 one. And over here on this page, you can see there's just a huge list of Python modules. And these are basically modules inside of Python that you can just access. So essentially there's like all of this awesome code that's already been written for you. And so if there's some sort of functionality that you want to have inside of your Python program, chances are there's a module in here that has that functionality. So there's all sorts of stuff you can do. I mean, if you just look through this list, like you'll see a huge collection of basically just, you know, a bunch of either Python variables or Python functions, just, you know, things that you can use to make your programs better. So here's what I would recommend. Like, head over to this page and just sort of look through a lot of these different modules, you know, see what you can see. And honestly, like if you click on one of them, it'll bring you to a page that talks about like how to use it. It'll tell you like how to import it and just, you know, some basics about it. And this is sort of like the list that's on the official Python docs. But here's the other thing. The Python community is huge. There's tons of developers who use Python, and you can actually find a lot of third-party modules. So if you just go online and, you know, look up like Python module for doing X or Python module for doing Y, chances are somebody out there has already written a Python module to do what you're trying to do. So if you get good at using modules and you get good at, you know, looking for them and finding them, you can actually save yourself a bunch of time because chances are that somebody's already written a module to do, you know, what you're trying to do or like part of what you're trying to do. So now that we've taken a look at all these different Python modules, I want to just kind of dive in a little bit deeper into how we can actually use these things. So you'll notice here there's a lot of files, right? There's a lot of different modules that we apparently have access to in Python. But the question is, where are all these files stored, right? When I was over here in my program, for example, I was using this usefultools.py file. Like I knew where that was. I created that file. I was directly involved in making it, and I just imported it over here. It was pretty easy, right? But what about all of these files, right? What about all these modules over here? Like where are all of these stored? And there's basically two types of modules here. There's built-in modules, which means they're just built into the Python language, so we kind of just automatically have access to them. And there's external modules. And a lot of these external modules are just stored in basically the same folder that we installed Python on our computer. So for example, let's look at a couple of these, right? We have like base64, BDB, bin ASCII. Like if I come over here, and you'll see I'm over here in my little file explorer, I have my Python project, which is draft. There's also this other folder over here called external libraries. If I was to click down on this and I come down here, you can see it's just the version of Python that I'm using. There's a folder here called lib, and this is a very important folder. This is basically storing all of those external modules. So you can see if I scroll down here, we have all of these different like modules, right? So here's that base64, here's BDB, right? A lot of these external modules are stored inside of this lib folder. And like I said, there's external modules. There's also a few modules that are just like built-in modules. They're not going to be stored inside of here. And you can actually tell, so for example, if I was to come over here and click on base64, it tells me where the source code is. So the source code's in lib/base64. We were able to see that, right? I saw that inside of my lib folder. This bin ASCII though, for example, if I click on this, you'll notice that this isn't giving me a folder because this is basically just like built in Python. So we don't have to worry about, locating that file. It just kind of works. So some of these are external, some of them are built in, and I want to show you guys, in addition to using these modules, right? So there's a lot of good stuff here, and honestly, you could spend years and years just learning about all these different modules. But a lot of times you're going to want to use modules that other people have written, and there's a lot of developers who work on Python and who write different modules. So there's a lot of useful modules out there that aren't included in this list, right? They're not going to be inside of this lib folder by default. And what we can actually do is we can install those external modules, those third-party modules that don't just come pre-installed with Python. And I'm going to show you guys how to do that really quick. So the first thing you need to do, obviously, is find a Python module that you want to install, that you want to download. And I've actually used one in the past, Python docs. It's an external module that you can use to basically use Python to create Word documents, which is pretty cool. So you can format Word documents inside of it. So I'm just going to look that up here in Google. I'm just going to type in Python docs. And look, here's the thing. There's tons of these external modules. You don't have to use Python docs. I'm just giving you guys an example. But really, if you just look up useful third-party Python modules, there's going to be lists of hundreds of these things online. In my case, though, Python docs has a website, and it basically just has some installation instructions. So I'm going to come over here, and it tells me that I can install Python docs using the command pip install Python docs. So this brings us to something I want to talk to you guys about, which is pip. And pip is essentially a program. And actually, if you have a newer version of Python 3, it comes pre-installed with Python 3. And you can use pip to install Python modules. It's referred to as a package manager. And a package manager basically just allows you to install, manage, update, and uninstall different Python modules. So pip is extremely useful. And in order for us to install Python docs, we're going to have to use pip. So I'm going to show you guys how we can do that. What I want to do is open up the command prompt or the terminal on my computer. If you're on a Mac, you want to open up your terminal. If you're on a Windows computer, you want to open up your command prompt. I'm using a Windows right now, so I'm just going to come down to the search bar and type in CMD, and this command prompt should come up. So I'm going to click this. Inside the command prompt, we can actually use pip. The first thing we want to do is just check to make sure that pip's installed. And like I said, if you have a newer version of Python 3, pip should come just pre-installed, and it should just work in here. If you don't have a newer version of Python 3, though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just going to check to make sure that I have it. I'm going to type in pip -- version, and it should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or third-party, and it should spit out the version of pip that I currently have. So as long as we have pip Python 3, though, you might have to install pip separately. And there's tons of instructions online on how to install pip. So I'm just going to check to make sure that I have it. I'm going to type in pip -- version, and it should spit out the version of pip that I currently have. So as long as we have pip, then we're ready to install an external or third-party Python module. All I have to do is just say pip install, and now I just want to type in the name of the Python module. So in the case of Python docs, it was just Python docs like that. Now again, you don't have to install Python docs. I'm just doing this for this tutorial, just kind of show you guys how this is going to work. But what you want to do is go online and look up some third-party external Python modules. And generally, I'd say 90 to 95% of the time, you're going to be able to just install them using pip. In the off case that you can't install them using pip, chances are there'll be some detailed installation instructions. But I would say for the most part, any legitimate Python module is going to be able to install it using pip. So over here, I'm just going to say pip install and then the module name, so Python-docs. And when I click enter, this is going to go off and install Python docs for us. So I'm just going to click enter, and it's going to go off and install everything we need for Python docs. So you can see we successfully installed Python docs 0.8.6. So I'm going to show you guys where exactly this got placed. So normally when we install a external third-party module, it's going to get put inside of this lib folder, but it's going to get put inside of a special folder in here called site packages. So site packages is a special folder, and if I open this folder, you'll see now we have this docs folder, and we also have this Python docs 0.8.6 py3.6.ag.info folder. So these two folders are basically included in that module installation. So you can see this docs folder has a bunch of different Python files and has a bunch of stuff in here that we can use. So if I wanted to use this inside of one of my programs, I'm just going to refer to the name of the module. So in our case, it's just going to be docs. So I used Python docs in order to install it, but we're going to use docs if we want to import it. So I could come up here and I could say import docx, and now I can actually use it. So I can just say docs dot whatever. And you can see there's a bunch of different stuff down here. There's a document part, image part. There's a bunch of stuff that we can use with this. And obviously, depending on the Python module you install, there's going to be different instructions. But you can see it got stored down here in this site packages folder. If I wanted to remove this, I could use pip to do it. So I could just say pip uninstall, and we could just, again, say the module name, so Python docs. And pip will now uninstall this on our computer. So if I was to go back over to this folder, you'll see that those two, that docs folder and then that other folder disappeared. So they're no longer here, and I'm actually not going to be able to use this anymore. So that's sort of the ins and outs of using modules. Now again, there's tons of these modules, and I can make dozens and dozens of Python courses covering each one of these modules. The built-in modules, the modules that are included by default, and external modules. There's tons of these things out there. And really, as a Python programmer now, what you can do is you can go out and play around with these different modules. I showed you the ins and outs of installing them, and you can use pip to install all these different modules. And you can make sure that you have them by checking the site packages folder or the libs folder. But really now it's on you to just kind of go out and use these modules, and don't shy away from this, because modules are a huge part of Python, and you're definitely going to want to include them in your Python stack. In this tutorial, I want to talk to you guys about classes and objects in Python. Now, classes and objects are extremely useful in Python programming, and they can help you to make your programs more organized and more powerful. So when we're in Python, we're dealing with all types of data, right? And a lot of times when we're writing programs, we're going to have to work with different types of data. And there's essentially like a few basic types of data we can deal with, usually things like strings, so like plain text, numbers, and Boolean values. Those three are kind of like the main types of data that you're going to be working with in Python. And we have all sorts of structures we can use to store that data, things like lists or dictionaries. But here's the problem, is that not all information, not all data, not all things can be represented using strings, numbers, or Booleans, right? There's a lot of things in the real world that we can't represent in something like a string or just a number, right? In other words, think of something like a phone or a computer or a person, right? You can't really represent those things in like a string or a number. In other words, like the data types that we have available to us in Python can't cover that. And so what we can do with classes and objects is we can essentially create our own data types. So I can create my own data type for anything I want in Python. So I could create like a phone data type, and it could represent a phone. So I could store all the information I would ever want to know about my phone inside of that data type. And in Python, we could create a class for it. And essentially what a class is it's just saying, hey, here's another data type that we want to use in Python. So with a class, you can essentially define your own data type, and it's super awesome. Classes are extremely useful. Classes are used in almost every single major programming language out there. So in this tutorial, I just want to give you guys a basic introduction of classes and using them inside of Python. So let's say that I'm writing a program and I want to represent a student inside of this program. So maybe I'm writing a program for like a college or a university. Let's say that in this program, I want to model a student. Like I want to model a real world object and I want it to be a student, right? We don't have a student data type, and I can't really represent a student in just a single string or a number. So what I can actually do is I can create a class for a student, and I'm basically creating like a student data type. So I'm gonna show you guys how we can do that and create our student class. So over here, I'm just gonna make a new file. We'll just make it a new Python file. So I'm just gonna call it student.py. And inside of this student.py file, I wanna create a student class. So the way that I can do that is just by typing class, and now I want to type the name of the class that I want to create. So in our case, we're going to create a class called student. So I'm just going to say student, and now we're going to make a colon. Now everything that goes inside of here is going to be inside of our student class. So everything that's indented like this will be considered a part of our student class. And basically what we can do inside of the student class is we can define a bunch of attributes about the student. So essentially what I'm doing is I'm like modeling a student. I'm creating our student data type. And I can use things like strings, integers, and Booleans in order to map out what a student should be and what a student should have. So I want to create something called an initialize function. And the way I do that is just by typing out def, and I'm just going to type 2 underscores, and then the word init, and then 2 more underscores. And you also want to type out open close parentheses, and inside of those parentheses, we want to type out self, and then we want a colon after that. What I can do inside of this initialize function is I can basically map out what attributes a student should have. So we can essentially define like, hey, here's the student data type in Python. So what I want to do is add in certain attributes after this self. So I'm just going to say self, a comma, and now we can start thinking about, what values will represent a student inside of our Python program. So if I'm thinking something like name, right? So every student in our program should have a name. They also might want to have a major because they're in college. They probably also will have a GPA, so their grade point average, like how they're doing in school. And let's define one more thing. Let me think. Why don't we make a Boolean, and it's going to be called is on probation. And this will basically tell whether or not the student is on probation. So essentially what I'm doing inside of this initialize method, inside of this init function, is I'm defining what a student is in our program. And so in this program, a student has a name, it has a major, it has a GPA, and it has a value that determines whether or not it's on probation. This right here is the student data type. So if I'm representing a student inside my program now, it has all of these attributes associated to it. And that's basically what I'm doing up here. Now, inside of this initialize function, we actually have to do something. And basically what I want to do is assign some values. So I'm going to be writing out some stuff, and this might not make total sense right now, but this is going to make sense in a second after we create our first student object. So just stick with me right now and just basically know that we have to do what I'm doing over here. So I'm just going to say self.name is equal to name. And then I'm going to say self.major is equal to major. Self.gpa is equal to GPA. And I'm going to say self.is on probation is equal to is on probation. So again, this might not make a whole lot of sense right now, but in a little bit, this is going to make total sense. So now that I have this student class defined, I can actually use this class inside of my other files. So I'm going to come over here into this app.python file, and this is just my main file. So I actually want to create a student, right? So in that student class, we defined the student data type. And we basically said like, hey, a student has a name, a major, a GPA, and it says whether or not they're on probation. That's like the template for what a student is. But we can actually create a student. So we can create an actual student and give it some information. And that's called an object. So this student class over here is basically defining what a student is. So a class is just like an overview of what the student data type is. An object is an actual student. So it's an actual student with a name, a major, and a GPA. It's not just this template anymore. It's actually like a student that we're representing inside of our program. So in order to use that student class and create a student object, I actually need to import that. So all I have to do over here is just say from student, and this is referring to this student file. I can say import student. And basically what this is saying is from the student file, I want to import the student class. So even though these are both student, they're referring to different things. So this is referring to the file, and this is referring to the actual student class. So now that we did this, we can create a student. So you can create an object of a class a lot like you would a normal variable. So I can just give it a name. I'm going to call this student1, and I'm just going to set it equal to student, and I'm going to make an open and close parentheses. And now inside of this parentheses, I want to give this student a name, a major, a GPA, and an is on probation value. So I'm going to say, we'll just create a fake student. So I'll just say his name's Jim, and he's studying business, and we want to give him a GPA, so maybe he has like a 3.1. And finally, we want to say whether or not the student is on probation. So why don't we say false? So basically what I'm doing is I'm saying that I want to create a student. So I want to actually create a student object. And remember, an object is just an instance of a class. So the class is like an overall template. It defines what a student is. But an object is an actual student with actual information. So we could call student1 now, this is a student object. So I just want to show you guys what this student object actually is and what we can do with it. And then I'm going to talk some more about that init function from before. So over here, I'm just going to make a print statement. And inside of here, I just want to print out student. And what's cool about this student1 object is I can actually access each of the attributes from inside of this object. So if I wanted to get the name of the student, I could say student1.name. And now this is actually going to print out the student's name. So over here, you'll see it prints out Jim. If I wanted, I could print out the student's GPA, and it's going to print out the student's GPA, 3.1. So now that I created this student object, I can actually access the information about the student. So essentially, I've just created a student data type. So I could create as many of these students as I wanted. If I wanted, I could create another student. We could call it student2. And essentially, we do the same thing. We just give it different information. So we could say like Pam, and her major is art, and she has like a 2.5, and let's say that she is on probation. So now I have another student, student2. So if I wanted, I could access information about that student. We could say like student2.gpa. And now this is giving me the GPA of student2. So basically what I did was I created a student data type, and I created student objects, and now I'm able to represent a student inside of my program. So let's talk real quick about all this stuff over here, because I didn't really explain it. Basically what's happening is when I come over here and I say student, and I'm passing in all of these different values, those are getting passed into this init function. So remember, I passed in a name, I passed in a major, I passed in a GPA. When we create that student, we're actually calling this function. And when I pass in the name, the major, and the GPA, those values are actually getting stored over here in this name, this major, this GPA, etc. Right? So I'm giving this student object all of that information. And down here, what I'm doing is I'm saying self.name is equal to name. And basically what this means is the actual object's name is going to be equal to the name that they passed in. So self.name is an attribute of student, right? So the student is storing a name, the student is storing a major, the student is storing a GPA. But that's different from this name, this major, and this GPA. Remember, these are all just values that I passed in. They're just parameters. And so I need to take the values that I passed in, and I need to assign them to the actual attributes of the object. So I need to say, okay, the name of the student is going to be equal to the name that we passed in. One more time. The name of the student object is going to be equal to the name that we passed in. The name of the student's major is going to be equal to the major that we passed in. The student's GPA, so it's for the object is equal, right? I can model anything that I wanted inside of my data types, score, and if statements, and loops. And a little multiple classes is we can model real-world objects, and we can create our own data types. in this tutorial, I'm gonna show you guys how to build a multiple choice quiz in Python. So basically we're gonna set up a little multiple choice quiz and we'll have the user take the quiz, and as they take the quiz, we'll keep track of their score, and then at the end we'll tell them how they did. So this is gonna be a pretty cool video. I'm excited to show you guys how to do this, and we'll get to use things like classes and if statements and loops in order to build this program. So we're gonna use a lot of cool stuff in Python. The first thing I wanna show you guys, I actually did this before I started the video. It's this little array, it's called question prompts. And I basically just wrote out all the questions that are gonna be, or I shouldn't say the questions, I wrote out all the question prompts that are gonna be inside of my multiple choice quiz. So the first one just says, what color are apples? And the answers are red, purple, or orange. The next one is, what color are bananas? The options are teal, magenta, and yellow. And the third question is, what color are strawberries? And the options are yellow, red, and blue. So this is obviously a very, very easy multiple choice quiz, but I just kind of wrote out the questions beforehand so I didn't have to spend time doing that. So let's talk about how we can build a multiple choice test. Well, the first thing I want to think about is, how can I represent the questions in the test, right? Over here we have the question prompts, but there's actually two parts to a question when you think about it. There's the prompt, in other words, like the actual question itself, and then there's the answer to the question. And both of those attributes need to be kept track of, right? I need to keep track of what we want to ask, and I need to keep track of what the answer is. So what I'm actually going to do is create a question class. So I'm going to create a little data type for questions, and inside of that question class, we'll be able to store the question prompts, and we'll also be able to store the question's answer. So I'm just going to come over here to my folder, and I'm going to make a new Python file, and we're just going to call this question.py. So we'll call it question.py, and inside of this question.py file, I'm going to make class. So I'm just going to say class question, and I'm going to put a colon here. So inside of this question class, we want to define an initialize function. So I'm going to say def 2 underscores init 2 underscores, and then we're going to type out an open and close parentheses self and then a colon. So after this self, we want to define the different attributes that will describe or that will be included in a question. So we're going to include a prompt and we're going to include an answer. So every question will have a question prompt and a question answer. Now down here, I want to take those values and assign them to the actual class object. So I'm going to say self.prompt is equal to prompt, and I'm going to say self.answer is equal to answer. So now we have a question class set up, and we can store all the information we need about a question. So what I want to do now is go back over to my app.python file, and we're actually going to create an array of questions. So I have over here these 3 prompts, and I'm actually just going to create another array. So we'll just call it questions, and I'm just going to set it equal to 2 open and close square brackets, and we're going to start creating question objects. So I can just say create an array of questions. So I have over here these 3 prompts, and I'm actually just going to create another array. So we'll just call it questions, and I'm just going to set it equal to 2 open and close square brackets, and we're going to start creating question objects. So I can just say the first element in this questions array will be a question, and we want to pass question prompts 0, and the answer to the first question was A, red, green. That's the color of apple. So I'm going to pass that first question, and I'm also going to pass the answer, which is A. And you'll see down here I'm getting an error, so it's saying unresolved reference question. So actually what we need to do before we can create these questions is we need to import this question class. So I'm going to come up here and say from question import question. So now down here in this questions array, we're not getting that error anymore. So we created one question object, and I'm just going to create a couple more for these other ones. So I'm just going to copy this one, and we will paste this down here. All right, so now we're creating two other questions, and these ones are going to be 1 and 2. And the answer to the second question is C, and the answer to the third question, I think it's B. Let me look. Yeah, so it's C and B. All right, so essentially what we're doing is we're creating 3 questions. Each one is getting a different question prompt, and they're each getting different answers. So now we have an array of questions that we want to ask on our test. So the next step is to actually write a function that will run the test, right? It has to ask the user the questions, and it has to check to see if they got the answer right. So down here, lower in the file, let's create a function. So I'm just going to say def, and we'll call this run test. And inside of this parentheses, we're going to take one parameter into this function. We're going to take a list of questions. So I'm just going to say questions. So this is basically going to be a list of question objects that we want to ask the user. So once I'm in here, all I want to do is loop through all the questions. So I want to loop through each question. I want to ask it to the user. I want to get the user's answer, and I want to check to see if it's right. And we need to be able to keep track of how the user does through the test. So I want to create a variable called score. And I'm just going to set it equal to 0. So every time the user answers a question right, we'll increment this score variable. All right, so what I want to do is, like I said, loop through all the questions in that questions array. So I'm going to create a for loop. I'm going to say for question in questions. So in other words, for each question object inside of this questions array, I want to do something. And basically, the first thing I want to do is ask the user the question. And I want to store their response inside of a variable. So I'm going to make a variable down here called answer. And this is going to represent the user's answer to the question. And I'm going to set it equal to input. And I need to give this a prompt. So I'm actually going to give this the prompt for the question. So I can just say question.prompt. So now I have the answer that the user entered in, which is stored inside this variable. So we want to check to see if they got the question right. And I can do that using an if statement. So I can say if answer, and this refers to the student's answer, is equal to question.answer. So I'm checking to see if the answer that the student gave is equal to the answer of the current question that we're asking. And if this is true, then I just want to increment score. So I'm going to say score plus equals 1. And this basically just means we're adding 1 to the score. So the last thing I want to do inside of this function is just print out the result. So I want to print out how the user did. So down here, I'm just going to say print, and I'm basically just going to print out like, hey, you got like 2 out of 3 questions, or you got 5 out of 6 questions right, or you got 0 out of 10 questions right. We'll just print out how they did. So I'll just say you got, and now I want to print out how many questions they got right. So this is just going to be the score. And in order to print a number alongside of a string like this, I'm going to have to say str and then type in the number. So we'll say str score. So we'll basically say you got however many they got right out of, so we'll use this little /, and now we'll just say how many questions there were. So we can say, and again, we're gonna have to convert this to a string because it's gonna be a number. So we can say string, and now we'll just say how many questions there were. So we can say, and again, we're gonna have to convert this to a string because it's gonna be a number. So we can say string, and then we want to figure out how many questions were in that questions array. So I can say len, and inside of here we can just say questions. So this is kind of like this long statement just to print out how many questions there were. So then over here I'll just say correct. All right, so now we have this print statement, and it's just gonna be printing out how many questions they got right. So let's see if this works. The last thing I need to do is just call this run test function. So I'll say run test, and I'm just gonna pass it that questions array that we created before. So we created this questions array with all of these question objects inside of it. I'm basically just gonna pass that into this run test function. So now let's run our program and see how we did. Hopefully we don't get any errors. There's a lot of code there, so it's possible that we might. Okay, so it says, what color are apples? This is a tough one. All right, let's put A, so we'll get the first question right. What color are bananas? Let's get the second question wrong. So I'm gonna say B, bananas are magenta. And we'll get the third question right. So it says, what color are strawberries? I'll just put B because that's the right answer. So now you'll see that our program prints out you got 2 out of 3 correct. So not only did it ask us all the questions and get our input for each question, but it also kept track of our score and it printed it out. So why don't we run through the test one more time, and we'll just like get 2 wrong this time. So I'll get this one wrong, I'll get this one wrong, and I'll get this one right. So now it says you got 1 out of 3 correct. So it's able to actually grade our test. And what's cool about the program we just wrote is if I wanted, I could add another question into here and it would automatically be able to ask it. So it doesn't matter how many questions we put in here, it's just able to ask it. So really the point I was trying to make with this whole video was just how we can use something like a class in order to model a real world entity. So for example, we created this question class and we were able to store all the information about a question that we could ever need. So we were able to store like the prompt and the answer. So we created our own question data type, and then we were able to create a bunch of different questions, pass it into this run test method, and it was able to grade the test and just run the test really easily. So that's kind of the point. So hopefully this makes sense. You know, this was a lot of code. So if you don't fully understand what I did, go back, watch the video, you know, try it a couple times on your own and see if you can create your own multiple choice test. In this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class or it can give us specific information about those objects. Over here, I have this student.py file, and inside of here, I created a put in the invalid key, instead of saying none, it's going to go ahead and say not a valid key. So this is going to give us like a default value. In this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class, or it can give us specific information about those objects. Over here, I have this student.py file. And inside of here, I created a student class. So I just had a class student, and I gave this student a couple of different attributes. I gave it a name, a major, and a GPA. So I can give this student all of this information. So when I create a student object, it'll have all of that information in it. Now over here on this app.py file, I've actually created two students. So student 1 is Oscar, who's studying accounting, and he has a GPA of 3.1. Student 2 is Phyllis, who's studying business, and she has a 3.8. So what we can actually do is we can use functions inside of these class files. So I could actually define a function inside of this student class, and then all of my student objects could access it. So for example, I could come down here and create a function, and let's say we wanted to create a function that all of my student objects could access it. So for example, I come down here and create a function, and let's say we wanted to create a function that told us whether or not this particular student had honors, so whether or not they were on the honor roll, right? Basically, like studying account. Now over here on this app, so I can give this student all of this information. So, and I gave this student this student class, and it can class functions in Python. So in this tutorial, I want to talk to you guys about class functions in Python. So a class function is essentially a function that we can use inside of a class, and it can either modify the objects of that class, or it can give us specific information about those objects. Over here, I have this student.py file, and inside of here, I created a student class. So I just had a class student, and I gave this student a couple of different attributes. I gave it a name, a major, and a GPA. So I can give this student all of this information. So when I create a student object, it'll have all of that information in it. Now over here on this app.py file, I've actually created two students. So student 1 is Oscar, who's studying accounting, and he has a GPA of 3.1. Student 2 is Phyllis, who's studying business, and she has a 3.8. So what we can actually do is we can use functions inside of these class files. So I could actually define a function inside of this student class, and then all of my student objects could access it. So for example, I could come down here and create a function, and let's say we wanted to create a function that told us whether or not this particular student had honors, so whether or not they were on the honor roll, right? Basically, like, are they like a really good student? So I could define a function called honor roll, and basically what it's going to do, it's going to tell me whether or not this particular student is on the honor roll. And let's basically just say the rules for being on honor roll is you have to have a GPA of 3.5 or above. So if your GPA is 3.5 or above, that means you're on the honor roll. Well, over here, I could actually write the code for that. So I could say if self.gpa. And when I say self over here, this is referring to like the actual student's GPA. And you'll notice over here, I have to pass that in as a parameter. And that always has to be the first parameter. So I could say if self.gpa is greater than or equal to 3.5, then we can return true because this student is on the honor roll. Otherwise, else we can just return false because if their GPA isn't above a 3.5, then they're not on the honor roll. So that's essentially our little on honor roll function. And you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm going to see if student 1 is on the honor roll. So now when I run this, you'll see it should print out false. False. And it's printing out false down here because I on honor roll function. And you can see it's a very small function, but it provides a service to the objects of this class, right? It allows the objects of this class to figure out whether or not that current student is on the honor roll. So over in this app.py file, I could just print out that value. So I could say print, and I'm going to see if student 1 is on the honor roll. So now when I run this, you'll see it should print out false. And it's printing out false down here because student 1 only has a GPA of 3.1. If I was to do the same thing on student 2, student 2 has a GPA of 3.8, so we should return true. And that's exactly what happened. So essentially a class function is just a little function that can be used by the objects of the class. And I would say this is a pretty good example of like what a class function should be doing. It should be like giving us information about the class, or it could also be like modifying information about the class. And so that's the basics of using functions in classes. I mean, this is a pretty simple tutorial, but I really just wanted to introduce you guys to the concept of putting functions inside of classes. This is gonna be really useful. And if you're making a class, you always want to think about like what functions can I put inside of here that will, you know, essentially help the user to either figure out information about the object or modify different values in the object. In this tutorial, I want to talk to you guys about inheritance in Python. Now, inheritance is basically where we can define a bunch of attributes and functions and things inside of a class, and then we can create another class and we can inherit all of those attributes. So I could basically have one class that has all the functionality of another class without having to physically write out any of the same methods or attributes. So if that's confusing, don't worry. I'm going to show you guys exactly what this is in this video. So let me show you about some stuff I have set up over here. I created this class called chef, and over here we just have this class chef, and inside of this chef class we have 3 functions. So this chef can do 3 things. The chef can make chicken, the chef can make salad, and the chef can make a special dish. And whenever the chef makes a dish, he basically just says the chef makes a chicken, or the chef makes a salad, or the chef makes barbecue ribs for this special dish. It's basically just saying whatever the chef is doing. So if I was to come over here to my app.python file, you'll notice that I'm importing the chef. So I'm basically allowed to use this chef class now. And I can say my chef is equal to chef. So I'm creating a new chef. So now if I came down here and I said my chef dot make chicken, when I run my program, now it's going to say the chef makes a chicken. If I said make special dish, and I run the program, now it's going to say the chef makes barbecue ribs, right? Because that's the chef's special dish. So I have this really awesome chef class, and it works really well. But let's say that I wanted to create another class to model another type of chef, right? So this chef class is just modeling like some generic chef, right? We're representing some generic chef in our program. But let's say that I wanted to create a class that modeled a different type of chef. For example, let's say we wanted to create a class that modeled a Chinese chef. So instead of just a normal chef, this is a Chinese chef. Well, I actually created a file over here called ChineseChef.python. So we could actually use this ChineseChef.python file to create our Chinese chef class. So I'm just going to say class, and over here I'm just going to say Chinese chef. And basically, I just can define everything that the Chinese chef can do. But let's say that our Chinese chef can do everything that our generic chef can do. So the Chinese chef is like a special chef, right? It's a very specific type of chef. But let's say that this Chinese chef can do everything that the normal chef can do. So the Chinese chef can make chicken, can make salad, and can also make a special dish. Well, if I wanted to give this Chinese chef all of that functionality, I could just come over here and I could copy all of these functions and I could paste them in here. And so now the Chinese chef can do everything that the other chef can do. But let's say that in addition to all of these things, the Chinese chef can also make a special dish called fried rice. So I could say def, and we could say make fried rice. So the Chinese chef has this extra function which allows it to make fried rice, and over here we can just say the chef makes fried rice. And let's also say that the Chinese chef has a different special dish. So instead of making barbecue ribs, the Chinese chef makes orange chicken. All right, so now we have our Chinese chef class set up, and you'll notice that it can do everything that the normal chef can do. So let's go back over to our app.python file, and I want to create a Chinese chef object. So instead of importing from chef, we're going to just import it from Chinese chef. So I'll say Chinese chef, and we're going to import Chinese chef. So let's go ahead and make a Chinese chef object. So down here, I'm going to make one, and I'll just say and then my Chinese chef, we can print out this special dish. So remember, the Chinese chef can do everything that the normal chef could do. So if I say my Chinese chef.make special dish, when I run this program, you'll see the regular chef is making barbecue ribs and the Chinese chef is making orange chicken. So everything works out. And this Chinese chef also has an extra method called make fried rice, and he can also make fried rice. But here's the problem, right? When I go over here to this ChineseChef.py, when I wanted to use all of the functionality that was inside this chef class, I actually had to copy and physically paste all of these functions down into this file, right? And that's kind of a drag. I mean, especially like, imagine if this chef had like 20 or 30 of these different functions in it. Well, I'd have to copy and I'd have to paste all of those inside of this Chinese chef. And this is where we can use something called inheritance. So instead of having to copy and paste all of these functions, I could just inherit these functions from that chef class. And in order to do that, I can actually just get rid of all of these, and I can come over here and right next to where I'm saying class Chinese chef, inside of parentheses, I can say the name of the class that I want to inherit from. So I can just say chef. And I'm also going to have to import this. So I'm going to come over here and we'll say from chef, import chef. So basically what this is saying is inside of this Chinese chef, I want to be able to use all of the functions that are contained inside of the chef class. So I'll say that one more time. Inside of this Chinese chef class, I want to be able to use all of the functions that are inside of this chef class. So by using inheritance here, I'm actually able to come over here to this app.py file, and now I'm still able to execute, for example, like the make chicken function. Even though I didn't specify the make chicken function in here, I didn't write it out, I can still run this program, and the Chinese chef will still be able to make chicken. So when I run this program, you'll see down here it says the chef makes chicken. And that's because I inherited the make chicken method from the chef class. But here's one thing that got messed up. If I come over here and I say make special dish, remember the Chinese chef special dish was supposed to be orange chicken, but now the Chinese chef is going to be making barbecue ribs because I inherited this make special dish function from this chef class. And so what I can actually do is I could come in here and I could override that make special dish class. So I could say def make special dish, and down here I can just override it. So I could say the chef make orange chicken. And now when I go over here and I run this make special dish function, now the chef's going to be back to making orange chicken. So the Chinese chef will make his special dish. So that's basically what inheritance does. It allows me to inherit functionality from an existing class into the new class. And I can actually just inherit all of it without having to write it out. So I didn't have to write out make chicken and make salad inside the Chinese class, but the Chinese chef can still make chicken and salad because it inherited that functionality from the chef class. In this tutorial, I want to talk to you guys about the Python interpreter. The Python interpreter is basically a little environment that we can use to execute Python commands. So it's kind of like this little sandbox environment where we can test out and try out different Python commands or different Python functions in a very safe and neutral environment. So it's kind of like a quick and dirty way to write Python and try different things out. And the way we use the Python interpreter is by opening up our command prompt. Now, if you're on Windows, there's a program called command prompt. If you're on Mac, there's a program called terminal. And basically, you need to open that program in order to use the Python interpreter. So I'm here on a Mac, but if you're on a Windows, you can essentially do exactly what I'm doing just inside of the command prompt. So on Mac here, I'm just going to search for my terminal. If you're on Windows, you can just search for like CMD or command prompt and it should pop up. So the terminal is basically an environment on our computer where we can interact with the computer and do different things without a graphical user interface. So normally when we interact with the computer, we're using things like buttons or windows, and we can move stuff around. We can basically just like interact with the computer with graphics. But the terminal or the command prompt is a place where we can interact with the computer using text commands. So I'm not gonna get too much into what the terminal and the command prompt are, but that's essentially what it is. So inside of here, we can use the Python interpreter. And the Python interpreter is basically just a little program that, like I said, we can write, sort of Python in. So generally, all you have to do is go over to your terminal or your command prompt and type in Python 3. And since we're using Python 3, I'm gonna type Python 3, but you can also just type normal Python, and I'm pretty sure that gives you Python 2. Now, here's a quick disclaimer. On Windows, you may run into a problem where you can't use this Python 3 command, and it's possible that if you're running into that problem, Python 3 hasn't been added to your Windows path variable. And basically what that means is your computer doesn't recognize the command Python 3. If that's the case, all you have to do is just go and Google how to add Python 3 to your Windows path variable. It's really easy. I'm not gonna get into it in this video just because it's kind of outside the scope, but if you're running into that problem, that's probably it. It's not on your Windows path variable. So just Google around for that and you should be able to find an answer. But I'm gonna type Python 3 and I'm gonna click enter, and it's gonna open up this cool little thing down here. So you can see it basically just says here's the version of Python. Now, I'm just gonna enter so we can have some new lines here. But down here, this is the Python interpreter. So we can write Python code in here and it's gonna work. So for example, I could write print, and inside of here I could print hello world. And when I click enter, you'll see that it prints out hello world. I could create a variable. So for example, I could say num1 is equal to 10. I could say num2 is equal to 90. And then I could print out num1 plus num2. And it's gonna be able to do that for me. I could also use something like a function. So I could define a function in here. We could make a function that's called say hi, and it'll take a name parameter. And you'll see here, when it saw I wanted to create a function, it put these 3 little dots, and I can indent in and we can write the code for our function. So I can say print hello I, and able to do, I can say and code that's probably it. Open up this cool little thing down here, so you can see it basically just says here's the version of Python. Now I'm just gonna enter so we can have some new lines here. But down here, this is the Python interpreter. So we can write Python code in here and it's gonna work. So for example, I could write print, and inside of here I could print hello world. And when I click enter, you'll see that it prints out hello world. I could create a variable. So for example, I could say num1 is equal to 10. I could say num2 is equal to 90. And then I could print out num1 plus num2. And it's gonna be able to do that for me. I could also use something like a function. So I could define a function in here. We can make a function that's called say hi, and it'll take a name parameter. And you'll see here, when it saw I wanted to create a function, it put these 3 little dots, and I can indent in and we can write the code for our function. So I can say print hello plus name. And now I have a function called say hi. So I can break out of this by just entering again. And I can call the function. So I could say hi, and it'll say hi to me. Hi, Mike. So now it's going to say, hello, Mike. So I can use a function. I could use something like an if statement, I could say, I could use something like a for loop. We could use while loops. I mean, we can basically use all of the basic Python commands and, inside of this Python interpreter. And like I said before, it's essentially just an environment where you can test out Python code. Now, this is not a place where you want to write any serious Python scripts. So if you're designing and writing a Python program, I would not recommend doing it inside of this interpreter. It's not a very intuitive environment. It's pretty much just set up for some quick and dirty tests. If you need to test something out, great. This is a perfect place for it because you don't have to set up a file. You don't have to use some IDE. You don't have to execute a file. You just go in here. It's quick. It's dirty. You get it done. But if you're writing an actual program, you definitely want to use a text editor. The text editor, it's just going to be way more organized. Everything's going to be a lot clearer, and you're not going to get confused with where stuff is and what you have. So that's the basics of the Python interpreter. You know, in the course, I haven't really been using it at all, just because I think it's a lot easier to teach when we're inside of a file than inside of here. But, you know, don't count this guy out. The Python interpreter is awesome. A lot of people use it, and it's great if you just need to test, you know, little bits of code out without having to set up some huge environment. So Python interpreter, definitely awesome. I would play around with it, you know, have some fun and take advantage of it. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute. Hey, welcome to Draft Academy. My name is Mike. In this tutorial, I'm going to show you guys how to build a multiple choice quiz in Python. So basically, we're going to set up a little multiple choice quiz, and we'll have the user take the quiz, and as they take the quiz, we'll keep track of their score, and then at the end, we'll tell them. Come up here and say, from
Hello again, everybody. So today we're going to create a quiz game in Python. Let's declare all of the different collections and variables that we'll need first. We will need a tuple of questions, a 2D tuple of options. My quiz will have 5 questions, but you can add more or less questions. Then a tuple of answers, a list of guesses. We will be appending guesses to our list. That's why we're using a list rather than a tuple. A score variable, which I will set to be 0. Then question number. This variable will keep track of what number question we're on. Alright, let's begin with our questions. I have 5. Here are my questions. They're all science related. Feel free to choose your own. This is what I have. How many elements are in the periodic table? Which animal lays the largest eggs? What is the most abundant gas in Earth's atmosphere? How many bones are in the human body? Which planet in the solar system is the hottest? These are the questions, but we'll need options. Let's add 4 options for every question. That's why we're using a 2-dimensional tuple. Each inner tuple will consist of 4 elements. They will be options A, B, C, or D. Let's copy these elements, then paste them within each tuple. This first element corresponds to my first question. How many elements are in the periodic table? I'll come up with some answers. I'll add some answers for the rest of these tuples too. We have a tuple of correct answers. The orders are C, D, A, B. If you come up with your own options, your answers may be different. Now that we have all of our different collections and variables taken care of, let's display each question. I will iterate over our tuple of questions. They are iterable. For every question, in questions, I'm going to print some decorative text. I think that's probably good. Then I will print each question we're iterating over. So let's see what we have so far. There's all 5 questions. After we display every question, I need to display every option. For every option in options. Our options is a 2D tuple. Let's add the index operator. The index is going to be our question number variable. It's a number. So at first, we're accessing options at index of 0, then 1, 2, 3, 4, 5. We will print every option in options at a given row number. Let's test this. Okay, we have some options, but all of these options are for the first question. We will need to increment our question number. So let's do that maybe here. Question number plus equals 1. That is much better. Before iterating the question number, we will ask the user for a guess. Guess equals input, enter, A, B, C, D. In case the user types in something that's lowercase, I will follow this input with the upper method to make the user input uppercase. We will take our list of guesses, use the append method, add our guess to that list. If our guess is equal to the answers tuple at index of question number, that means the user guessed the right answer. Let's increase the user score. Score plus equals 1. Then print the word correct. Correct. Else, we will print incorrect. I'll use an F string. Our answers at index of question number is the correct answer. All right, let's answer some of these questions. C, correct. Which animal lays the largest eggs? Definitely the whale, because the whale's the largest creature, right? Incorrect. D is the correct answer. What is the most abundant gas in Earth's atmosphere? Nitrogen. Correct. How many bones are in the human body? D. That is incorrect. A is the right answer. Which planet in the solar system is the hottest? Mercury, because it's closest to the sun, right? Wrong. Incorrect. B is the correct answer. We're keeping track of our answers successfully. Once we complete all the questions, let's print the results. I'm going to add some decorative text. Not necessary, but I think it would look cool. I will display the results. We will iterate over all of the answers and the guesses. Print answers. I'm going to set the ending character to be an empty string. For every answer in answers, print each answer. I will set the ending character to be a space to separate each answer. Then I'll add a new print line. Let's do this with guesses. Change answers to guesses. For every guess in guesses, print each guess. Okay, I'm going to run this again. I'm just going to make up some answers. A, B, C, D, A. Here are the correct answers. Here are the guesses. I guessed none of them right. Then we will print a score. Score equals, take our score, divided by, I'm going to use the length function, then pass in our questions. How many elements are within our questions tuple? Then I will multiply all of this by 100 to give us a percentage. Then typecast this whole formula as an integer. So we're basically just reassigning our score variable. Then let's print using an F string. Your score is our score variable, then add percent. I'm going to intentionally get all the answers right. C, D, A, B. Here are the answers. Here are your guesses. Your scores.
follow my lead. Well, I found a girl. I fell in love with you.
Yellow diamonds in the light. I was standing.
You said that we would always be. Without you, I feel lost at sea. Through the darkness, you'd hide with me. Like the wind, we'd be wild and free. You said you'd follow me anywhere. Through your eyes, you tell me you won't be there. I gotta learn how to love without you. I gotta carry my cross without you. Stuck in the middle and I'm just about to figure it out without you. And I'm done sitting on without you. Fuck, I'm going out without you. I'm gonna tear the city down without you. I'm going Bonnie and Clyde without you. Now I'm running away, my dear, from myself and the truth I fear. My heart is beating, I can't see clear. How I'm wishing that you were here. You said you follow me anywhere. Through your eyes, tell me you won't be there. I gotta learn how to love without you. I gotta carry my cross without you. Stuck in the middle and I'm just about to figure it out without you. And I'm done sitting home without you. Fuck, I'm going out without you. I'm gonna tear the city down without you. I'm going Bonnie and Clyde without you.
Feeling my way through the darkness, guided by a beating heart. I can't tell where the journey will end, but I know where to start. They tell me I'm too young to understand. They say I'm caught up in a dream. Well, life will pass me by if I don't open up my eyes. So that's fine by me. So wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself and I didn't know I was lost. So wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself and I didn't know I could stay forever this young. Not afraid to close my eyes. Life's a game made for everyone, and love is the prize. So wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself, and I didn't know I was lost. So wake me up when it's all over, when I'm wiser and I'm older. All this time I was finding myself, and I didn't know I was lost. 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 I didn't know.
Once upon a younger year, when all our shadows disappeared, the animals inside came out to play. Went face to face with all our fears, learned our lessons through the tears, made memories we knew would never fade. One day my father, he told me, son, don't let it slip away. He took me in his arms, I heard him say, when you get older, your wild heart will live for younger days. Think of me if ever you're afraid. He said one day you'll leave this world behind, so live a life you will remember. My father told me when I was just a child, these are the nights that never die. My father told me. Can't put out, carve your name into those shining stars. He said go venture far beyond the shores, don't forsake this life of yours. I'll guide you home no matter where you are. One day my father, he told me, son, don't let it slip away. When I was just a kid, I heard him say, when you get older, your wild heart will live for younger days. Think of me if ever you're afraid. He said one day you'll leave this world behind, so live a life you will remember. My father told me when I was just a child, these are the nights that never die. My father told me. These are the nights that never die. My father told me.
flip